Hey everyone. So today I was messing around and I made this cool multi-slider. And if you've seen some of my Max for Live devices, you know that uh, I've made multi-sliders that look like this in the past. And I use jsui for those, which is a way in Max that you can basically make custom UI objects using JavaScript. But there's also perhaps less known a way that you can use JavaScript with your UI objects, and it's using this thing called jspainter, which allows you to basically take over the rendering of any, not any, I don't think, but many native Max or Max for Live UI objects. So in this particular case, this is actually the multi-slider object, but I have a jspainter file, which is some JavaScript code that I've written that changes how this is rendered, which is really cool. And what this means is that when I interact with this, as far as Max is concerned, it's the same as me interacting with a normal multi-slider. So you can see here that I'm still just getting a big list of numbers here. And the interaction, it just behaves exactly like a multi-slider. But I don't really like how the sliders look in Max, and they don't look good in Max for Live at all because it's just a different visual style. So this is a really good way to solve that problem because I can just write some different code that renders the sliders and makes them a little bit look a little bit different. And if I want to be able to configure those sliders with some attributes, I can basically take over the attributes that the multi-slider object has, and then use those to control my rendering code. So in this case, I use the spacing attribute to actually control the kind of width of these little handles. The thickness is the thickness of the handles. I can set the orientation. And also I used, because I kind of ran out of parameters, I also used some of these colors, just not as colors, but just as another source of numbers. So the kind of thickness of this bar is actually controlled by the opacity of this candy cane color 1 attribute. So multi-slider is actually kind of a good candidate for this use as a takeoverable UI object because it gives you a bunch of these extra attributes that you can use to control your object. When you're thinking about whether to use JSUI or JSPainter, I would think about it this way. If you are making something that somebody is going to interact with, so it's not just like a visualizer, but it's actually something that somebody's going to control, then I would say try to use JSPainter. And when you discover that if you discover that you can't for whatever reason, then you can use JSUI or V8UI. If you are making just purely a visualizer, then you're safe to use JSUI and V8UI. And the reason for this is JSPainter, because it attaches itself to an existing Max or Max for Live UI object, works a little bit better with the parameter system. It definitely works better with accessibility features that your computer has. So if you, for example, make Max for Live devices and you want to make sure that people who use screen readers and other accessibility tools have a good experience using your device, then using JSPainter is better because, and this is something that I actually learned from one of the users of my devices who was generous enough with his time to kind of teach me what the experience of a visually impaired person is when they use software. So JSPainter, because it attaches itself to a parameter, works a lot better with those tools, and probably in other ways works a little bit more seamlessly with um, the Max parameter system. It's also a little bit easier to write these because you don't have to basically define a whole bunch of parameters and you don't have to write any of the interaction code, which is pretty awesome. So like all this kind of, you know, response to the sliders and all these things and the outputting of the values, that's all handled by the multi-slider, and all I'm doing is just writing the code that does the visual part. Okay, so let me show you how this is done. I think the way that I want to do this is just take this code that I already have and just paste it off on the side and then delete it, and we'll start from scratch, because that's kind of a fun way to do it. So I'll save here, and then this will go away. And I am going to start with a fresh multi-slider, and I'm going to paste it here. Okay. And then I'm going to add the name of my file, which is pdm.jspainter.multislider.js. And you can see that now we don't see anything. I'm going to give it 8 sliders, and we're going to get started. So auto watch is equal to 1. This is something you basically always want to do when you're writing JavaScript in Max, because it just tells the object that's using that JavaScript to look for changes that you make to your file and automatically apply them. The next thing that we're going to do is create a paint function, which is the rendering function. And to start off, we'll actually just tell the object to render the original UI that multi-slider has. So I can call this function mgraphics.parentPaint and save. And I think I may have to copy and paste replace to get that. Oh, what's going on here? Parent paint is not a function. Did I spell it wrong? Parent, maybe it's like that. There we go. So we are now just using the jspainter to tell multi-slider to do what it would normally do. Okay. But now let's go a little bit further. So, in fact, what we'll do is we'll just render things on top for now, on top of the original UI, so that we can kind of see what's going on more easily. So the jspainter allows you to talk to the object and get its values. It doesn't allow you to set the values. So these slider values are whatever the multi-slider says they are, based on the messages that you send to the object and the interactions that you have to it. You can't set them from within the code, but you can get them, and you can also get all the attributes. So we'll start by getting the values. So we'll say var values equals box.getValueOf, and we'll print this to the console. And with multi-slider, the object has a range. So yeah, value range, which by default is -1 to 1. And we're going to want to know what that is. So we'll take this advantage. We'll take this opportunity to get that as well. So we'll call this range, and we'll say box.getAdder. And that attribute is called setMinMax in multi-slider, which is a bit of a weird name, but that's what it is. Okay. And we'll print that as well. So post range. And now if we come over here and we open the console, we can see that it's telling us those things. And if I slide around here, then you can see that it continues to tell me those things. So what we're going to want to do here basically is, let's start off by just making a little dot that sits on each one of these sliders, these like little thin line sliders. And so to do that, we're going to need a few things. Number one, we're going to need to know like what's the X and Y. Well, really all we need to know is what's the X and Y position of these, and then what's the kind of like dimensions of that circle. So to get the X position, basically we're going to just slice this horizontal space up into 8 slices, or however many sliders there are. And we could know how many sliders there are in 2 ways. We can either query the object for its size attribute using this same kind of method. So we can say box.getAdderSize, or we can just, having already gotten the values, just look at the size of the array that's returned, right? Because the return from this box.getValueOf function is always an array. Actually, in fact, even if you're using like live.dial, which is a UI object that can only store a single value, it actually still returns an array. So we could say var let's call it size. Size is equal to values.length, and we'll print that to the console as well. There we go. So then we can basically say, we know how many there are, and now we need to know what the width of this canvas is, so that we know basically how much horizontal space is allocated to each of these sliders, so that we can then go over each of them and get the X position of each of them. So we can say var space per slider is going to be equal to the width divided by the size. And we don't know yet what the width is, so we have to calculate that. So var width is equal to, I think it's box.rect, this.box.rect, 2 minus this.box.rect 0, var height is equal to, so these 4 items in this.box.rect array are the position of the left boundary, then the top, then the right boundary, then the bottom, I believed. So we're basically just have to do some math in order to translate from those kind of absolute positions of those 4 edges of the box into the height and width. I believe I got that right, so let's again print it and then we can check. Height. Okay. 425 by 470. If we go into the inspector, great, that's correct. Okay, cool. So then we can say space per slider is width over size. So again, let's just print space per slider, 53.12 pixels. And so now we are at the point where we're ready to identify the X position. So we can say for each slider basically. So starting from 0 and going up to size -1. Oops. Oops. So we're going to iterate over these sliders, and we can say that var x is going to be I times space per slider. And let's just start by drawing a circle. So we're going to use mgraphics, and I don't know if I mentioned this. mgraphics is the drawing library that Max provides for drawing in JavaScript. And the first thing that we're going to do is just make a circle at that X position, and then just in the middle position of the canvas, so height divided by 2, and then we need to give it a width and a height of the circle. So when we do this, what we're doing is creating a path, and then we need to tell Max to actually fill in that path with the fill function. And so that should now give us a row of dots across the screen here. And there's a few things. Well, they're black. They're kind of like way over on the left side. They're like crunched all the way up on the left, because the kind of origin point, like when I say these X and Y coordinates of this path, it's actually doing it in the kind of upper left-hand corner of each of them. So we need to correct that. But let's first actually just make them a little bit bigger. And we'll also make them white. So we'll use another mgraphics function to do that. Set source RGBA 1111. And that should make them white and bigger. And then we want to just nudge them over so that they land in the middle. So let's actually define a variable that's going to be the diameter of the dot. Okay, so we'll just do that in line. This is something that you would probably normally do up here. In most code that you write, you would do it outside of the function, but we're actually going to do it inside, because eventually we're going to be assigning the value of this variable with a value that we query from the attribute of the object, right? So like, for example, this spacing attribute, we would get it from there, and we're going to do that inside of this code. So I'm just going to say var, but for now I'll just set it to something. So we'll say dot or let's just call it diameter is equal to 20, and then we'll replace these. And now we're going to add diameter over 2 to the x position. So now we've scooted those over so that they should, they still don't look like they're in the right spot exactly. That looks more correct. Let's see how that does for us. I think it should have been diameter over 2, but maybe these are actually radii rather than height and width, although I thought they were height and width. Anyway, we'll figure it out. So now we have these dots, but they're not like in the right positions on the y-axis. So the next thing to do is to figure out, okay, well, where should these actually be positioned on the y given the value of that dot. Now we know that the range is from -1 to 1, and what we want to probably try to do here is normalize these values to the range of 0 to 1, so that we can basically just multiply that by the height and get the correct y-axis position. So the first thing that we want to do here is normalize those values. And normalize basically just means taking a value that is on some range and then rescaling that value so that it fits between 0 and 1, but is proportionally in the same position between 0 and 1 that it is on the other range. So we'll write a function called normalize. We'll have our input value, our range low, and our range high. And then the function is going to be, we'll get the range itself by just subtracting low from high. And then we will return x minus low divided by the range. And I think, if I'm not making a mistake there, that will normalize for us. And so then for this particular array of the values, we can normalize them by saying, we'll just use a for loop for this. So for var I equals 0. If you're a JavaScript nerd, then you know that you could use map, array.map here, but we're just going to do things the old-fashioned way. But we do need to know that size first. I is less than size, I plus plus. And we'll say values I is equal to normalize values I. So we're reassigning that value basically. And we also need to know the range. So let's move this code up here. Range 0, so the low and the high. And so now we should see our values on the range of 0 to 1. If I bring one all the way up, it's the second to last one, it's 1. Now it's 0. Great. So now we should be able to, and let's clean up just a little bit here. We should be able to just multiply the value, so values times height to get the y position of the dot. And it looks better, but it's backwards, which is kind of goofy. So we will take 1 minus values I times height, because M graphics, or the sort of the coordinate system, I think makes, yeah, this is 0, 0. So because this is 0, 0, and this is width, height down here, we have to flip those y-axis values around. But now that works, and you can see that uh, the dot is just touching, kind of tangentially touching the line, and that's because we didn't do the same exercise of offsetting the y position that we did with the x position. It still looks like those x positions are a little bit off center, so I still have to figure out what mistake I made there. But let's fix the y's and see if along the way we can figure it out. So basically, I believe that all we need to do is subtract diameter over 2. Great, and now we're centered. And so now what have I done wrong here? So x plus, let's try diameter over 2 again. Huh, I'm confused. What if we just do x? Oh, you know what I think it is? It's because the multi-slider has this thin line thickness that offsets the little line, and so it looks like it's off center, but it's not. So I think it is plus diameter over 2. I think this is correct. It's just that Max is actually confusing us a little bit. Although it looks like the spacing here is not the same as the spacing on this side, so let's try just diameter. I'm clearly doing something wrong, but I don't know what it is, and this is close enough. And in fact, we're kind of at the point where we don't have to worry so much about rendering the original multi-slider design anymore, right? Cool. So now we have our dots, and let's now add some color. So we can, in the same way that we were able to get the range using this getAttr method of box, then we can do the same to get the color. If we go look at the inspector for the object, we can see that there's a slider color attribute. So I could say var slider color is equal to box.getAttr slider color. And then rather than setting the color to just white, I will set it to slider color. And so now they're the color of this. And I'll go ahead and use a dynamic color from the live theme. Great. And as perhaps a last thing, I will add the little like lines, which I thought were kind of cool. And before I do that, I'm going to actually change the range here to be on the range of 0 to 1. Uh-oh, what did I do? Oh, I made so many of them. 87. Actually, okay, so there's a couple things we should do. We should make it so that these dots, they're not always just 10. We should get the size of them. So let's do that. So we'll get the spacing parameter. So var spacing is equal to, it's all this code again. And then what I want to do is set this diameter. We'll basically treat the spacing like it's a percentage, and we'll have it be a percentage of the like the kind of slider's width. So space per slider. So we'll say spacing divided by 100 times space per slider. And that is currently a very small number, but if we set it to, which we can do here, something else like 50, then that looks good. And now I can see we're inching up on the edge, so I'm going to correct my X yet again. Okay, now things are starting to look somewhat correct. So I don't know what I did wrong, but things look generally okay now. And let's also do the same for the thickness. So we're going to kind of make these like lozenge shaped dots. They could be round like this, but they don't have to be. So we'll also get the thickness. And so we'll say this is going to be called the handle width, and then the handle height will be proportional to the handle width. So we'll call this thickness divided by 100 times handle width. And then we'll change this should become handle width, and this is handle width, and this is handle height, and this is handle height. Okay. And those are super skinny. There we go. So if we made this 100, then it will be a dot again, or we can make these kind of like ellipses. That looks good. Let's do nice big dots. And one other thing that occurred to me that I expected would be a problem is this, where we kind of like, we want the dot to sort of stop here rather than being able to go all the way to the end. So let's make that correction. So basically we need to subtract half of the thickness of the handle, or the height of the handle, from the range. So here, let's make some variables here. So var x, in fact, let's just do this. Okay, now y is going to be all of this. Okay, that looks a little bit better. So when we multiply here, we're going to want this to be the height minus the handle height, because we're basically making the total range, like, we're reducing the total range by 2 times half the handle height, because we have half the handle height on the top and half the handle height on the bottom. So that's getting us a little bit closer, but actually we're offset. So I think now we can actually take this away. And now we're good. Great. Okay, as a last thing, let's draw these little lines. So we're going to add another section here. In fact, we could still do it in the same for loop. So we'll say this is going to be the draw dot. And in fact, before we draw the dot, I want to draw the line because I want it to kind of end underneath the dot. And the things that you do later will be done on top. So we're going to create a line. So we'll say mgraphics dot set line width. And for now, we'll just start with a line width of 3. But we'll make this configurable as well. And then now what we'll do, so rather than creating a path using just a single function like we did with the ellipse, we're actually going to create our own path. And the way that we do that is by basically kind of moving around to different coordinates within the canvas. And because it's a line, it's pretty simple. It's just 2 coordinates, so the beginning and the end of the line. But we always start the path with the move to function. So we're going to move to, and we want to set we want the X position already. And in fact, I think that we're going to want to start with just well, whatever. Let's stick with how this is. So we'll move to x0, and then let's just try mgraphics.move to x height, right? So we're just going to draw lines, and we'll use the same color also. We're just going to draw like longitudinal vertical lines, or at least we expect to. But we also, I made 2 mistakes here. The first is we move to x0, but then we have to say line to x height, and then that creates our path, which is just a line. and then we need to call mgraphics.stroke to actually draw that line. So now we should see these longitudinal lines, which looks good, but we can see that they're in the wrong place because we need to actually inch over even more for these to get into the center of them. We need to basically add half the handle width. So if I do this, then this puts the lines in the correct place, but it shifts the dots over too. So we can just modify that when we go to draw the dots. So we'll say x, we'll subtract basically handle width over 2 from the x position of the dot, and then that places them on these lines. And then I want to use the background color for the color of the line, and we'll just go with LCD background as the color. So var track color, we'll call it, is equal to box.getAtter LCD, I forget. BG color. And then we'll do this. So we're going to set our color down here for the dot, but up here for the line, set source RGB A. We'll use the track color. Great. So that's just a line from top to bottom. But let's also add one that goes, so let's keep this one, but then also add one that goes from the bottom to the dot. And I think that one is starting at X height and going to X Y, right? So we can also put Y up here, and we're going to add another line. So we'll say mgraphics.move to X height, and graphics line to XY, and then mgraphics.stroke. And for this, we want to use this color. So we can put this now here. So this is basically like draw the underlying track, and then this is like the active track, and then this is the dot. Let's see if we got that right. Uh-oh, something broke. Let's comment this out and see what went wrong. Okay, it was clearly here. Any errors? I misspelled mgraphics. It's a lot to type. Okay, cool. So that's that. Maybe we'll stop there. I think that's probably enough. I will show you the other code that does like all the rest. I'll copy this, put it somewhere else, and then copy my original code and save. And looks a little different. This is the one where I use the candy cane color. So I have to increase the number of candy canes in order to have access to this particular parameter. So I'll take you just through this a little bit. So one thing that was a little bit tricky to figure out was actually how to do the horizontal versus vertical, because this is a thing where basically like you need to, you essentially you render it like it's vertical and then you rotate it, but because you cannot always guarantee that the aspect ratio is 1, so you can't guarantee that the canvas is square, you need to do some extra math to like futz around. But there's some interesting stuff where we perform this rotation, which is here. So anytime that you need to like take the entire canvas and move everything in it or rotate all of it, then this is where you're going to do like matrix transformation. So you're basically doing linear algebra. And so there are these functions like translate and rotate that allow you to do those things. So what's interesting here is like up here, we're just getting a bunch of the attributes. This is all the same stuff that we did before, like getting the value and converting it, subtracting the value from one, all that kind of stuff. And then here we basically check to see, are we horizontal or vertical? And if we're horizontal, then we actually switch the width and the height, right? Because now we're just in a weird world where things are sideways. And then we rotate the entire canvas before performing all of the rendering, right? So rather than editing the code itself that does the drawing, you can actually just basically perform this kind of virtual rotation of the canvas and switching of the width and the height, and then more or less proceed as normal with drawing the sliders, and it works. There are a few cases where you still have to kind of acknowledge the orientation, and this has to do with this kind of counterintuitive inversion of the y-axis where the 0, 0 point is here, whereas in your brain you think that high is at the top and low is at the bottom for the y-axis, but it's actually the opposite because it's a computer graphics system, and that's how they tend to function. I think that's basically it. Oh, the last thing I wanted to show you was, so if you want to use this, well, obviously the code will be there for you, so you can, I'll put the basic version and this more advanced version in the repository. But we already saw that like in order to use this, you have to load in this code, and you also have to like have settings set to reasonable things, right? Like if I remove this and turn it back into a normal multi-slider, it's like a totally weird version of a multi-slider because we're kind of hijacking these parameters. So one thing that can be handy is you can kind of set it up so that it's in like a default state. That's the way that you would commonly want to use it. And then you can save what's called a prototype, which is basically like a preset for the attributes of a UI object. And so when you save the prototype, basically all the settings that you have here in the inspector, including the reference to the painter file, as well as all the other settings, is saved. So that makes it a lot quicker to be able to recall your custom UI thingy. So here's my kind of default version. And yeah, so you just create a multi-slider, and then you'd go to this little menu and you'd select your prototype. And maybe I'll edit my prototype because it's very large and long and tall, but you get the point, right? It gets you pretty close to doing what you needed to do. So I will include, and the prototype is it's actually in your Max library. So if you go into Max 9 prototypes, that's where it is. I will add it in, I'll just include it, and you may have to copy it over into this prototypes folder in order to get it to work for you. Okay, thanks so much. Talk to you next time. Bye-bye.